Hello. This is going to be a showcase of a project of mine that I've completed a couple months back. It's basically a cloud storage app. So think Dropbox, Google Drive, Microsoft's OneDrive, right? Very similar concept. And this is what the app looks like. Okay. Now, before we dive into it, I just want to say that there are chapters in this video, chapters or sections, whatever you want to call it. You can skip to the different sections. It's listed in the description, okay? So without further ado, let's get started. So let's talk about the features of the app first. So this is what the homepage looks like. I can do some navigation, pretty simple. And there are breadcrumbs up here, right? So I just clicked a breadcrumb there and it took me back, right? So pretty simple there. These are the files and these are the folders, right? So let's upload a file. I'll just upload this one here. So I can drag and drop. Actually, let's upload a couple of files here. Why not? So I can drag and drop, and there you go, right? And if I change my mind, I can do that. So let's say I don't want to upload these two here. I can delete those, click upload, and it would only upload this particular file. And just to show you that it is uploaded, I can come back to my S3 bucket. I can refresh. I'm sorting the objects by the last modified attribute, and so this should be the one. This should be the file that I uploaded. Okay, so I can click download. It's gonna download it, and I can view it, and there you go. Right, that's the file that I uploaded. Just to show you as a site, the exact same file. I opened this one as well. And there you go. It's the exact same file, okay? So, upload works. I guess I haven't tested the download feature, so I'll download that. Open it. Again, it's the exact same file, okay? It's not corrupted. It's not meddled or, it's the exact same copy. And that's pretty much it. Now, the search function doesn't work. If I have time, I would definitely look into that. But as of now, it does not work. And another feature is authentication. So I can log out. Yep, I want to log out. And if I come back to the website, I would have to log back in, okay? Now, something that you notice there is that the login and logout URLs are actually forwarded to a different URL, and that's actually normal, because I don't want to get into it now, but we'll discuss about it in the architecture section, okay? That's pretty much it, and that's pretty much the whole features of the app. This is not an error. It's just I'm using a dev key. I'm using a dev key, but it thinks that I'm in production, which I'm not. I'm still on local host, but yeah, that's okay. It's not an error. Right, so let's talk about the architecture side. So in terms of architecture, the front end is built using Next.js, React, and Shadcn. Shadcn is a UI library. The reason why I used the UI library is because I couldn't be bothered building the UI from scratch. The main goal of this project was to learn about authentication, S3, and just backend stuff, not so much focus on the front end. So I decided to use a UI library to speed things up on the front end. And in terms of the back end, obviously I used S3 bucket. It's also a Postgres database that is used to record each file's metadata. So things like where does this particular file belong to, right? I know it belongs to this user, but in which directory does it belong to, right? So that's that. And there's also a user database, but it's actually managed by Auth0, by the authentication service that I'm using. I could use my own database and have Auth0 forward requests and store, user info in my database instead, but it's a bit difficult to set up, and this is my first time using this service, so I didn't want to get in too deep, but I could definitely do that if I wanted to, right? And so S3 bucket, Postgres database, and a user database that is used and managed by Okta. Another thing is I'm using self-signed certificate to get HTTPS connections, which is very important if you're using Auth0, because, well, it's very important if you're using Auth0 with Next.js, because the way it works is a lot of things would break if you're not using an HTTPS connection, okay? So I managed to set up HTTPS with self-signed certificates by using a service called Caddy. And you just set up a reverse proxy and you start the service, and it would proxy the original socket for you and provide your certificates for those sockets. So it's pretty cool. And that's pretty much it for the backend. Now, I guess the most important thing is, why did I use the frameworks that I used, right? In terms of the front end, Next.js here was used because I thought that, well, okay, to be fair, I thought that server components are really, really good. So I wanted to use server components as much as possible. But what ended up happening is this very jumbled mess of code of interleaving server components and client components. So that was 400 lines. This is another 220 lines, right? If I was building everything entirely with client components, it wouldn't be this long. But because I was trying my best to use server components, it actually became very messy and things look like this. Now, looking back, it's probably better to just stick with client components, because the only benefit that comes with server components is if your users are using devices that are very slow in terms of computation power, or you're trying to get better SEO, so search engine optimization, or you're trying to improve some performance benchmarks in Lighthouse, right? But considering that this is a very, very dynamic app, I think it's not much use to, it's not that beneficial to use server components, right? Because the users of this app is going to run devices that are powerful enough to upload and download files and process them efficiently, right? That's one thing. And in terms of search engine optimization, I mean, there's nothing to optimize for. It's a very dynamic app. All of these files, the content is private to this particular user, right? So there's no really benefit to using server components. So I made a mistake there. Okay, I should have just used completely client components or just disregard Next.js in general and just used plain React or just plain HTML and CSS for that matter. But when I started, I thought, server components is always king. But now, at the end of the project, I realized that, hey, server components is in everything. And I should have just sticked with client components instead, or just plain React. Now, in terms of the backend, S3 bucket is definitely justified. I mean, I don't know how it's not. It's very clearly justified. Now, as for the metadata database, I could have used a different database vendor. It doesn't have to be Postgres, but I've never used Postgres before, so I just thought, why not just build something with Postgres so that I can learn a little bit about the syntax and how it works. But it could very well be built with any other database vendor, SQL Server, MySQL, right? So it doesn't really matter. And that's pretty much it. Now, I guess the most interesting part is how is the file uploads and downloads implemented, right? That's the core features of this app. So the way it works, when you upload a file, it's streamed to the backend server, and then the backend server streams the contents of the files to S3 by using something called a multi-part upload. So with the S3 SDK for JavaScript, you can upload files or objects rather in two ways. You can upload it completely, or you can upload it in multiple parts, right? And the backend server of this app uploads the files in multiple parts. So what it does is the user uploads a file and the contents of the file is streamed to the backend server. And I'll just show you here so it's a little bit easier. Now, the backend server waits for the contents of the stream to reach 5 megabytes. I know it's technically not megabytes because there's an I in here. It's megabytes or something like that. But it waits for it to reach roughly 5 megabytes or over the the 5 megabytes minimum threshold, and then it creates a multi-part upload and uploads the contents to S3, right? And that's essentially how it works. So the file is not actually temporarily stored on the hard drive. Okay, everything is in memory, everything is stream based, so it's not stored on the hard drive, it's just directly streamed to S3. And downloads work in a similar way. So if I show you the code for downloads here, there you go. This is the code for downloads. So it tries to get the object from S3, and then it streams back to the user. So everything is stream based. It's not files aren't temporarily stored in the backend server on the hard drive, right? Everything is just stream based. So everything is just in memory, and the hard drive storage is not used at all. And that's pretty much it for the uploads and downloads. Now, in terms of error handling, that is when it gets a little bit difficult. So the way it works right now, if there is an error during the upload phase, everything is just terminated, right? All of the previous objects, all of the previous contents of the files that were uploaded is deleted from S3, okay? Similarly, for downloads, it's just everything just gets terminated immediately, right? So that's not good. I don't think that's the most efficient way. Arguably, what you could have done is when an upload error occurs, right? Because when you're uploading a file, you break it up into multiple parts and uploading each part separately. So if an error occurs while you're uploading a particular part, what you could do is just show an error to the user that, hey, that particular part didn't go through successfully, but all the other parts did, right? So when a user uploads the exact same file later, then you don't have to completely start over, right? You can just resume where the error occurred, and that would streamline the uploads and speed it up. However, it's a little bit difficult to implement, right? And again, the main goal of this project is not to go too heavily into the architecture side, but just to interact and get some hands-on experience with S3, Postgres, authentication. It was not a goal to build a perfect perfect error handling app, essentially. But yeah, looking back, I could definitely do that, right? So another thing is, I didn't know this before, but a couple of things. So I've learned is, one, it's the error handling, right? And secondly, AWS's SDK for S3, the SDK in general, it actually has some error handling capabilities as well. So in S3, for example, if an upload doesn't go through, the SDK automatically retries the upload a couple of times before giving up, essentially, right? So it does that via something called exponential backoff. And what it is, it's a very fancy name, but essentially what it is, it's going to wait 1 second, right? And then it's going to retry the upload after 1 second. And if that upload didn't go through, it's going to wait 2 seconds, and it's going to retry the upload again. And if that didn't go through, it's going to wait 4 seconds, right? And then 8 seconds, and so on and so forth. And at some point, after a number of tries, it's going to give up completely, right? So that exponential backoff strategy is automatically implemented. It's already implemented in the SDK itself, so developers don't have to manually implement that logic. So it's very good there. And yeah, that's pretty much it. Now, I understand that the uploading feature where I have the backend act as essentially a middleman is not a great idea. I know that the S3 presigned URL feature exists, and I could do it that way, where when the user wants to upload a file, they get a presigned URL, and they use that URL to upload the file directly to S3. So the backend server is not involved in this process. Well, it is involved in that process in the sense that it's going to request the presigned URL, but afterwards, the backend server is not involved at all, and that could definitely work. But another purpose of building this project is to also interact with Node.js streams, because prior to this project, I had never used Node.js streams before. So I decided to just have users stream their files to the backend server, and then the backend server would continue streaming that file to S3. Although arguably presigned URLs are better, right? And that's pretty much it. Thanks for watching.